Hello friends and welcome to Isife Edublog. Before we start, let's take a general preview of what we have in stock for you. Now, the first thing we'll be looking at will be the definition of indices. After which we'll look at the laws that guides operations under indices. Of which we'll be looking at our multiplication law, divisional law, zero law, fractional law, negative law, and power law. After which we'll look at some examples. Now after that, below or on your description box below, you'll find the link to all these things we have here. Now, if you need more exercises under indices, now this is a well-solved video exercise. Okay? Now, believe me, you cannot go through our exercises and still remain undefined in indices. So, if you want to get better, if you want to get rooted under indices, now this is the link for you. Now, still on our description box, you'll find the link to past questions, under indices from your JAMB, WAEC, NICO, GC, and your post-UTME. So if you're interested in that, now follow the link that will lead you to all these things. Now these are questions under indices. Now the last on our link is 500 boosters. Now this is a general problem solving in mathematics. Now this is something that gives a general summary of what you have in mathematics. Okay. Now and this is what your 500 boosters it is. Now it has your facts and formula sections, where a quick summary of what you have in mathematics is being done. Now it also has the question segment that contains every topic. Okay, so for these indices, you have questions under indices, and believe me, these are high-tech questions. Now these are defining questions under indices. So if you need a PDF or if you need a copy of this, now why not follow the link under your video that will take you to 500 boosters. What is indices? Indices is that area or that aspect in mathematics that shows us how many times a number is multiplying itself. And how does indices appear? Indices appear in this form. For example, if I have A superscript B, A raised to power B. Now this is indices. And this simply means A multiplying itself B number of places. So if I have 5 raised to power 3, this is simply 5 3 places, which is equal to 5 times 5 times 5, which is equal to 125. So basically, this is an indicial expression. So expressions that come in this form are known as indices. Now, in indices, this is known as the base, while this part is known as the index or power of this indicial expression. So for this expression, these parts, or for every indicial expression, the main part is known as the base, while the superscript part is known as the index or the power. Okay? So up next for us will be the laws of indices. Now these are the laws that guide calculations under indices. Okay, so every calculation we run under indices, there are certain laws that guide us depending on the form the question comes with. The first law we'll be looking at will be the multiplication law. What is this multiplication law all about? My multiplication law tells me that if I have A raised to power B times A raised to power C, that the solution is equal to A raised to power B plus C. What does this mean? It means that if I have two initial expressions of the same base multiplying out themselves, that the solution is simply the sum of their powers, maintaining the base. So for example, if I have 5 raised to power 3, 5 times 5 raised to power 4. From our multiplication law, it tells us that the solution is equal to 5 raised to power 3 plus 4, which is equal to 5 raised to power 7. Another good example is if we have something like 12 raised to power 5 times 12 raised to power 7. From our multiplication law, it tells us that the solution is equal to 12 raised to power 5 plus 7, which is equal to 12 raised to power 12. So this basically is what multiplication law is all about. So it is, if I have two initial expressions of the same base multiplying out themselves, the solution is simply the sum of their powers maintaining their base. Now what I want you to note that this law can only be applied to initial expressions or indices of the same base. So what does it mean? It means that if I have something like 3 raised to the power 2 times 5 raised to the power 3. Now if you look at these two initial expressions, my base here is 3, while my base here is 5. Now for these expressions, I cannot apply this multiplication law, since we say that this law is applied to only initial expressions of the same base. So the next law we'll be looking at will be what we know as our divisional law. Now what does this divisional law tell us? It tells us that a raised to the power b divided by a raised to the power c is equal to a raised to the power b minus c. So if I have two initial expressions of the same base dividing out themselves, the solution is equal to the difference of the two powers, maintaining the base. So an example, our first example will be if I have 12 raised to the power 7 divided by 12 raised to the power 5. From our divisional law, it tells us that the solution is equal to 12 raised to the power 7 minus 5, which is equal to 12 raised to the power 2. Another example, example 2. If we have 10 raised to the power 8 divided by 10 raised to the power 12, from our divisional law, it tells us that the solution to this is 10 raised to the power 8 minus 12, which is equal to 10 raised to the power minus 4. So basically, this is what our divisional law of indices tells us. Now, but please, I want you to note this. Just like what we said under multiplicational law, this law is only applicable to initial expressions of the same base. So it means that if I have 3 raised to the power 8 divided by 4 raised to the power 5, this is 3 raised to the power 8, this is 4 raised to the power 5. This base and this base, they are not the same. So I cannot apply this law to this very particular question. Zero law of indices. What is zero law of indices all about? This law tells us that anything in mathematics that is raised to the power of 0 is 1. So it means that 1 raised to the power 0 is 1, 2 raised to the power 0 is 1, 10 raised to the power 0 is 1, 100 raised to the power 0 is 1. So I have that a raised to the power 0 is equal to 1. 1000 raised to the power 0 is equal to 1. 10,000 raised to the power 0 is equal to 1. So this zero law simply tells us that no matter how big a number is, no matter how strange a number is, once that number is raised to the power of 0, its answer is simply 1. The next law we'll be looking at will be our fractional law. What does this law tell us? Now let's look at this expression we have. It tells us that a raised to the fraction of m over n, that the solution is equal to the nth root of a, all raised to the power of m. Okay? So remember, n is our denominator, m is our numerator. So we have the roots of our denominator all raised to the power of our numerator. So a good example 1, is if we have 25 raised to the power of 3 over 2. Now from this example we have here, from what we have here, it tells us that the solution is equal to the second root of 25 all raised to the power of 3. And we know that the second root of 25 is 5. So we have 5 all raised to the power of 3, which is equal to 5 times 5 times 5, which is equal to 1, 2, 5. So let's look at another example. Let's look at h to the power of 5 over 2. From what we have, it tells us that the solution to this is the second root of 64 all raised to the power of 5. So we have 64 squared all raised to the power of 5, which is equal to, now we know that the second root of the square root of 64 is 8. 8 raised to the power of 5, which is equal to 8 times 8 times 8 times 8 times 8. Alright? So basically this is what our fractional law is all about. The next law we'll be looking at is what we refer to as our negative law. What does this negative law tell us? It tells us that if I have a raised to the power of minus m, that my answer is equal to the inverse of my question. So I have a raised to the power minus m is equal to 1 over a raised to the power m. So if we have 12 raised to the power minus 2, from this it tells us that the solution is equal to 1 over 12 raised to the power 2, which is equal to 1 over 1, 4. Sorry? 1 all over 1, 4, 4. Another good example is this. If I have 64 raised to the power of minus 3 over 2. Alright? Now, from our negative one, it tells us that the solution is equal to 1 over 64 raised to the power of 3 over 2. Now, here we can apply our fractional law. So after that, this is equal to 1 over, now the second root of 64, all raised to the power of 3, which is equal to 1 over, we know that the second root of 64 is 8. So we have 8 all raised to the power of 3. So the next law we'll be looking at will be the law we know as our power law. What does power law mean? It means that if I have a raised to the power n, all raised to the power of n, that the solution is equal to a raised to the power of m times n. So it means that if I have 2 raised to the power 3, all raised to the power 5, that the solution to this is 2 raised to the power 3 times 5, which is equal to 2 raised to the power 15. Okay? So if we also have, another example is this. If we have 10 raised to the power 8, all raised to the power of 5. Now this tells us that the solution to this is 10 raised to the power 8 times 5, which is equal to 10 raised to the power of 40. So basically that is what this power law is all about. On the next for us is this. I want to point out this. A times b all raised to the power of m is equal to a raised to the power m times b raised to the power m. But a plus or minus b all raised to the power of m is not equal to a raised to the power m plus or minus b raised to the power m. So I want us to take note of this. Now this will be of great importance to us. Alright, now we are done with our laws of indices. So let's look at exercises and examples that have a combination of most or if not all of these laws in them. And the first example of the exercise we'll be looking at will be this. We have 25 all raised to the power of x minus 1 equal to 64 times 5 over 2 all raised to the power of 6. Now how do we start? The first thing to do is to write down our solution. Now this is 25 x raised to the power x raised to 25 raised to the power of x minus 1 equals 64 this raised to the power of this. Now we know that 25 is 5 raised to the power of 2. Then x minus 1 equal to 64 brackets 5. Now this is 5 raised to the power 6 all over 2 raised to the power 6. So this means that this power is for my numerator and for my denominator. So I'll separate them. So this is 5 squared all raised to the power x minus 1 equal to 64 brackets 5 raised to the power 6 all over. Now 2 raised to the power 6 is 64. So all over 64. So this is 5 squared x minus 1 equal to 64 times 5 raised to the power 6 all over 64. So this, we cancel out this. So I will have 5 squared all raised to the power x minus 1 equal to 5 raised to the power 6. Now, this will lead us to our power law, which tells us that the solution to this is 2 times x minus 1. So I'll have this to be equal to 5. 2 times x is 2x minus 2 times 1 is minus 2 equal to 5 raised to the power 6. Now this is 5, this is our power, 5 raised to the power 6. So it means that our powers are the same. So after that 2x minus 2 is equal to 6. Therefore, we'll have that 2x is equal to 6. Therefore x is equal to 8 over 2 is equal to 4. So from this we have our x to be 4. Now let's look at our second example. So example 2. Now this is our second example. Now from this we know that 9 is 3 raised to the power 2. So we'll write this very particular question to have 3 squared all raised to the power 2x minus 1 all over. Now we know that 27 is 3 raised to the power 3. 3 raised to the power 3 all raised to the power x plus 1 being equal to 1 over 1. Or let's say 1. Okay? So at this junction we'll cross and multiply. So this is this times 1 equal to this times 1. So from here we'll now have that 3 raised to the power 2 all raised to the power 2x minus 1 is equal to 3 raised to the power 3. All raised to the power of x plus 1. Alright? Now from this, we'll need to apply our power law. Now this is a power, this is a power, this is a power, this is a power. So our power law tells us that this is equal to 3 raised to the power, this times this. So we'll have 2 brackets, 2x minus 1, equal to 3 raised to the power 3 brackets x plus 1. So opening our bracket, to have 3 raised to the power 2 times this will give us 4x minus 2. And this is equal to 3 raised to the power. Opening this bracket, we'll have 3x plus 3. Alright? Now we have 3 raised to the power being equal to 3 raised to the power this. So this equal sign tells me that my powers are the same. So I'll have 4x minus 2 being equal to 3x plus 3. So I'll collect like terms. So I have 4x minus 3x equal to 3 plus 2. So 4x minus 3x will give us x. So I have that x is equal to 3 plus 2 equals 5.